Today we're going to talk about post processors and specifically 5-axis post processors, and kind of talk a little bit about what you need to know, some good things to be aware of if you're new to 5-axis programming and specifically to 5-axis posts. And to start off, I just kind of wanted to pose some questions. So this isn't, this isn't a test. It's not a pop quiz like it was in school. Really, this is just some questions that I think are useful, especially kind of from the shop owner perspective, to ask yourself about 5-axis. So I am doing a course on 5-axis post-processing, and that starts this Saturday. In the course, we're going to talk about a little bit about the setup of the Mastercam environment, so how to properly set up Mastercam for 5-axis machining, and we're going to talk a little bit about basic 5-axis toolpath creation. We're not going to go real in depth on there. Mostly it's just to make sure that we all understand the terminology that goes into configuring the generic Fanuc 5-axis mill post. So that's going to be the main focus of the class. We're actually going to set up that Fanuc post for both a table, a trunnion style machine, and a head style machine, a gantry machine. And then we're also going to write a simple 5-axis post from scratch, mainly just to demonstrate MP processing and the vector and matrix math that's available to you in the post processor. Really, the focus of the class is on using the generic Fanuc 5X mill post. And that's going to be the rest of what I'm going to talk about after we go through these questions, is why do we want to do that? So just some questions that I think it's useful to ask yourself. One of the things that I started thinking about as I put together this course is, why would you want to do your own 5-axis post processor? Why wouldn't you just want to go out and buy one for your specific machine? So these questions are kind of related to that whole process of, if I'm a shop and I'm getting into 5-axis, what are some of the things I need to be aware of? So, okay, let's get to the questions. So this is not meant to be insulting or to assume, that you don't know anything about 5-axis. I would ask these questions even of a shop that was already doing 5-axis machining. So how much do you know about the setup and operation of your specific 5-axis machine? Are you, along with that, and it was a question that I was just thinking about that I didn't add to this, what kind of setup and calibration are you doing? Do you have any kind of calibration schedule? Do the machines get ball bar tested and probed on an accurate basis? How well do you know your machine's control? The days of simple controllers are going away. So what do I mean by that? Well, most of the machines that are out on the market these days, the new machines that are coming out, have different modes and different codes for what we're used to. And just a quick example I put down here, for 3-axis machining we have G43. Now if you're a Fanuc guy or gal, like I am, Fanuc guy in this case, G43 is tool length compensation. Well, now on the higher end Fanuc controls, we've got multiple modes. Okay, we've got G43, G43.1, G43.2, G43.3, and G43.4, and they all do different things, and they are meant to be used in conjunction with other codes. So in order for you to be able to run some of these more high-tech modes that will do different types of compensation, whether it's workpiece error compensation, dynamic coordinate systems, tool center or rotary tool point control. There are these different modes that work together. So do your options work together? Programming. Setup and operation. So what are the guys that are setting up and running the machine doing on the shop floor? Documentation. Do you have good setup sheets and tool lists? Are they easy to generate? Your machine options. So are you utilizing all of the options that you bought, or Do you have a bunch of options you don't use? I've seen that. That's quite common. You know, a shop will buy it. They'll have these options, but they don't invest in figuring out how to make sure those options are utilized. What kind of tooling are you using? That'll make a difference. You know, if you're trying to hold tight tolerance parts, if you're trying to combine multiple setups into one, you're going to need more advanced tool holding. You know, hydraulic, heat shrink tool holders, there's all kinds of options. Work holding. Are you using dovetail vices, 5-axis vices, things like invertibles? Are you just using, you know, a vise that's bolted to your machine table? You know, are you doing any kind of pallet switching or automation? And last, simulation. Have you invested in an NC verification program, something like NC Simul or Vericut, or even a Simco Edit, something that will show the results of running real G-code? And what kind of training are you investing in? So if you're going to buy, you know, a $300,000 or a $500,000 machine or a couple $1 million 5-axis machine, what kind of training are you getting? You know, this kind of ties back into the questions about how well do you know your control. You know, one of the things that I would always recommend is that if you're getting a new machine on the shop floor, especially if it has a control you're unfamiliar with, pay for and schedule some time with an applications engineer. You know, you really need to make sure that at least the person responsible for programming and setting up and running the machine knows how to use those options. Are you doing any on-site training? Okay, internal training. Are you investing in internal training programs in your company to make sure that the knowledge gets passed on, make sure that people have room for growth? Are you investing in any consultants to come in? Are you having anybody look at your manufacturing process and doing things like identifying the bottlenecks? You know, we hear a lot about lean manufacturing, and to me, lean manufacturing is really identifying and eliminating the bottlenecks. Where does the material sit in your shop? Where does the money sit? Why do you have a bunch of work in process? Those are the kind of things that a consultant can help you identify. And finally, I guess the last question is, what kind of external training are you doing? There are costs associated with that. You know, traveling, hotel, airfare, the cost of the class itself. But often, if you're going to be investing in these new tools, simulation, a brand new machine, those type of things, then you also need to consider what you are providing yourself and your employees to take advantage of all these new options. You know, 5-axis machining is great. It's really powerful, and you can get a lot more done in a shorter amount of time, but you need to make sure that you're investing in that entire process. Okay, so enough of the questions and sales pitch. What I'm going to talk about for just a few more minutes is 5-axis post-processing. So what is a 5-axis machine? What is a 5-axis post-processor? I've got Mastercam. This happens to be Mastercam X7, and I just put together a quick little demonstration. So in this case, and we'll be going through this in our class on 5-axis post-processing. In order for you to turn the toolpaths that you wrote into accurate machine code for your machine, every CAM program on the market requires a post-processor. A post-processor is just a translator. Much like translating English to Spanish, or Spanish to German, or pick any two languages, the post-processor translates the generic code in Mastercam, which we call NCI data, stands for Numerical Control Intermediate, into NC code, into CAM data, so the actual code that's going to run your machine. I happen to have a post-processor linked in here, and we've got 6 operations. We've got a face and some contours. And if I select post the selected operations, first thing we're going to do is look at the NCI. So the NCI, again, is that intermediate file. And so what's going to happen here is when I write these operations, it is going to post an ASCII file that is generic. So this file that gets generated at this point has information about the motion of your tools, and it has information about the tool itself. So what kind of tool am I using, and how am I going to go and cut away my material? And all of this data is generic. So we have things like a tool change code. It says change my tool. And then we have motion code. And if you were to read through this, I can guarantee you that nowhere in here do we output a rotary angle. So what we're doing is taking the data that's presented here, and we are using that data to do the math calculations inside the post to output the XYZ location and the rotary values. That's what the post processor does. So it takes this information, and based on your machine type, it's going to translate it into machine code. So if I select these operations again and select NC file overwrite, we're going to output the machine code. So this now runs through the post processor, and we get data that is formatted to run on your machine. And Mastercam ships with the generic Fanuc 5X mill post. So if you are running a 5-axis machine, I'm just going and driving to this location here. It's shared MCAM X7 mill posts. And we take a look at the generic Fanuc 5X mill post. This post can be configured for almost any machine type. So one of the nice things about this is that your Mastercam software comes with a free 5-axis post processor that can be configured for just about any machine type. So literally this one post processor that I'm looking at right here, we can make multiple copies of it, and we can set it up for a head-head, a gantry style machine. We can set it up for a table-table, a trunnion style machine. We can set it up for a head table where one of the rotary axes is on the head, one of them is on the table, something like the DMU. And there is instructions in the top of this post processor that talk about how to set up the Mastercam file and how to do the setup of the 5-axis post. So that's what my class coming up is going to be about. It's going to be how to go through this post processor and do the setup and configuration to output good code for your machine. One of the things that you need to be aware of is that this class is going to focus on doing that for Fanuc-based controls. So we're taking the generic Fanuc 5X mill post, we're going to configure it for a table-table, something like the Mazak Variaxis style of machine, and then we're going to do a head-head, something like a CMS router or a Cincinnati router, any of those 5-axis gantry style routers. We're not going to be going in and changing the entire output of the post for something like, say, a Siemens. We don't have time in the 3 days of the class to do that. But I think for anybody that is getting into 5-axis post processing, the class is really going to cover all of the basic stuff that you need to know in how to use this post. So one of the things that is not unique about this post, but that you need to know, is that this post makes some pretty extensive use of the miscellaneous integers. So as you create these toolpaths, all of these toolpaths have switches that you can set. And if we scroll down and look at the MISC values page, all of these options in here where there is not the default text, the default text, it would say MISC reel 789, MISC reel 405. These have not been utilized. But the rest of these, all of these values influence the output of the post in some way. So for example, we can take the secondary axis, say that this was a table machine, and it was a Haas VFTR, for example. I know that's a pretty common machine. Lots of people have them. And your table and your rotary axis on your trunnion was rotating towards you so that it was hiding the part from the view of the operator. One of the things that we can set here is a switch. You notice that it says 1 equals POS, that stands for positive, 2 equals negative. So if we wanted to temporarily restrict the secondary axis, and we wanted to say force that A axis to go negative, I might set this to 2, and that would force it to go negative in my output. So we can use these miscellaneous values to control the post. Well, what else can we do? One of the options that we have available is a safe retract and approach. So one of the options in that miscellaneous integer category allows us to change when we retract. Do we disable all the retracts? We might want to do that if we were doing some kind of cavity work and we didn't want the tool to retract. Do we retract only at the null tool change? Do we retract and approach at both the null tool change and the regular tool change, etc.? So we've got a bunch of different switches that we can use to control that output. We are going to be going through and using the variables and the data that's in this post processor in order to do the configuration of the post. Now, if you're using one of the standard machine types, and by standard I'm talking table, head table, or head. These 4 variable definitions right here, rote axis 1 and rote dir 1, and rote axis 2 and rote dir 2, control the setup and configuration of the post. It doesn't matter what type of 5-axis machine you are configuring it for, as long as it's not a nutating. I'll throw a little caveat out there. There's some nutating type machines, and those are where the rotary axes themselves are not orthogonal. They're not 90 degrees to each other. But as long as you're using one of the standard type machines, these settings for these 4 variables will allow you to set up any combination of 2 rotary axes you want. So whether it's an A, a B, or a C, and whether it's mounted on the table or on the head, we can use these variables to configure that post. Now, there's obviously a little more to it than that. There are some other variables that control things like how the tool length gets applied if you're doing a head-head. There are some shift variables, so depending on the setup of your machine, we can offset the intersection of the rotary axes to handle any kind of error that's actually built into your machine. And there are some other settings like rotary limits. So we can configure the rotary limits to give you plus or minus control, or allow a rotary to even wind up if your machine will allow it to. One of the final things that we're going to go through, and it's one of the ones I think is most important, is the repositioning. So as we go around a part like this, what we want to have happen on the machine is we want the machine to kick the rotary axis over, depending on how this rotary is oriented, and then we want it to just kind of rotate to get to these different positions. When that happens, if you don't have your retracts in your operation set high enough at the start and the end, you can often get a crash at the actual machine tool. One of the options inside the post processor lets us automatically kick out these safe transition boundaries, and we can do it based on either our stock definition or the physical limits that are set in the post. And so we'll be going through all of those options, talking about how to set it up, how to configure this post processor for a variety of situations. And we'll also be going through and talking about the math functions and the actual math that's involved in calculating these angles. So if you really did want to write your own post processor, we would at least go through the starting info of where you could get started. I mean, this actual post processor, if it was unencrypted, is about 10,000 lines of code. I think even, this particular post, you can set it for any type of machine. So if you were going to create your own 5-axis from scratch solely based on one type of machine, you could probably do it in about 2,000 to 3,000 lines of code. But still, unless you really know what you're doing, that's a lot of code to go in and try and write yourself and to make everything work together. The nice thing about the generic Fanuc 5x mil post is that a lot of that heavy lifting is already done for you. So all you really need to know is how to go in and configure the post, and also how to debug where your output is coming from. Because a lot of the math is encrypted, it can sometimes be a little confusing about where you can and can't make edits and what you need to do. But I will guarantee you this: all of the output that occurs from the post, even though a big portion of it is binned up, all of that output occurs from the PST itself. What that means is that since all of the output is actually generated from the PST file, there is a way for you to override just about anything. So if you really do need to do some custom calculations or output some custom G or M codes, there's a way to get it done. You just have to be familiar enough with how this post is organized so that you can figure out how. And that's one of the things that I'll be showing you. So I think that's going to wrap up my portion. I think I went a little bit longer than I intended there, but I just wanted to give a little introduction to 5-axis post processing. We're going to be talking about it in depth in my basic 5-axis post class, and we're going to go through and configure the generic Fanuc 5x mil post for a table, so a trunnion style machine, and also for a head style machine. And one of the things that we do with our classes is we record all of the class sessions and we upload them to eApprentice servers and give everybody in the class a login. And so what that means is that you get access to those videos for life. So once you've taken the class, you can always go back and replay any of the portions of the video that you might want to use as a reference. And we do that not only for the main class videos themselves, but we also have a couple of sessions that we call office hours. So during the office hour sessions, I'll be holding those on Wednesday evenings, you can come in and basically sit down and work through your issues on your 5-axis post with me in a live format. So I can't promise that I'll be able to answer everybody's question. Some of the things that people may want to do are just going to take too much time to cover in the basic 5x post class, but I'll certainly be able to give you pointers, get you at least started, show you where to look in the documentation, and help you work through these issues. Because really, signing up for the class doesn't mean that I'm going to write a post processor for you. It means that I'm going to try and teach you how to do your own post modification so you can do it yourself, or so your programmer can learn how to do it, and they can serve your company's needs as you get new machines, get new controls in your shop. So I think that's about going to wrap it up for me. I'm going to go ahead and turn it back over to Derek, I believe.
Yeah, thanks, Colin. That was great.
Sure, thank you.
Well, so we've got a little bit of time left, guys. So if you would like to ask questions, now's the time. You've got a lot of 5-axis firepower sitting here on the meeting today. We've got Colin Gilchrist from CNC Software, post-processor developer for Mastercam. We also have Michael Witten online with us, who's very senior manufacturing engineer, very experienced in 5-axis programming. So go ahead, take your opportunities now. Let's see if we can get some questions going, and we'll talk to the guys. One thing I was thinking of as you were going through the presentation there, Colin. It's something that you and I have discussed. Sometimes looking at a post processor, it can be it's pretty complicated, and you need to be the right kind of person who's going to be able to get in there and learn how to code. But there are cases, I showed a slide earlier where we're working with a DMU50 using a Heidenhain control. In that case, the post was not based off of Fanuc-based control. We went out and purchased a post processor, and you can do that. But the post processor will never be perfect because, for one thing, the machines are all configured differently. And additionally, every shop wants to do things differently. So Colin and I have discussed this in the past. Really, every shop should have somebody in the programming department who can handle the posts. Maybe they're not an expert. Maybe they're not going to write every piece of code for the post, but that is the communication, the point person who can communicate with the post developer. Because even if you have somebody else develop a post for you, you're not going to want to wait for that person to be available every time you need to do a little change, like have the coolant turn on after the spindle comes down, or whatever particular minor modification you want to make. So it's still highly valuable for people who are not necessarily going to develop posts from scratch, but just want to be able to have the conversations with the post developers. So we got some questions coming in here. Let's see what we have. Question coming in from Kurt. Let me expand this a little bit so I can see it. What other posts do you cover other than Fanuc? And I'll let you run with that, Colin.
Well, Fanucs are the main ones we cover, just because that's the basic 5-axis. We only have Fanuc-based ones available as generic. So if you're running something like a Siemens or a Heidenhain, most of the time we actually recommend that you go to a third-party post provider, somebody who deals with those types of machines all the time. The ones that we typically recommend are in-house solutions or Postability. Both of those companies are out of Canada. There is Simco that is in, I want to say Denmark, I believe, and there are a couple of people out of Germany that also provide post processors, more for those, like the Heidenhain and the Siemens that you're going to find in those German-style markets. So I'm not opposed to doing a class in the future. I'd certainly be interested in doing a class in the future that dealt with some of those other types of controls, but it really depends on the market for it. I see Siemens maybe being the next biggest player in terms of number of controls installed, so I may think about doing one of those in the future. The reality is, if you took the generic Fanuc 5x mil class, you would at least be able to see how the logic is structured, and you could make those changes yourself if you knew enough about post-processor editing. Like I said, we don't have a generic Siemens 5-axis, and we don't have a generic Heidenhain 5-axis, but all of the Heidenhain and the Siemens posts that I have seen and dealt with from third-party post providers started life as the generic Fanuc 5x mil post. So even though the starting point is not close to what the final output would be for a Siemens or a Heidenhain, most people use the generic Fanuc 5x mil post and highly modify it to suit whatever control they want. Be it Siemens, be it a Cincinnati Achromatic, trying to think of some of the old weird ones that I've seen, a Boston-matic, Thermwood, and so on. There are some post providers that will write their own from scratch, but I would say that they are the exception rather than the rule. Most people are going to start with the generic Fanuc 5x mil post and make whatever changes they need, even if it's completely doctoring the output to suit something like a Siemens or a Heidenhain. But that's a great question. Thanks for asking.
Right. Thanks for that, Colin. And I should mention we've done business with all of the post developers Colin mentioned, in-house Postability, Simco. I'd add ICAM to that list
Oh,
as
sure.
another great post
Yep.
developer. Yeah, and I'm not sure why all the post developers seem to be from Canada, but that seems to be the hotbed of post processor development. So those are all great companies. So let's see, what's the difference, Colin, between a null tool change and a regular tool change?
Okay. A regular tool change is any time the tool number actually changes. So you're going to get, in the case of a Fanuc, you're going to get an M6. You're going to get the actual tool change code. A null tool change is an event in the NCI when the same tool number is used for another operation. So you actually have two, operations that are on different planes but use the same tool. So here in this case, on our facing op, we would do an actual tool change to tool number 1, and all of the rest of these operations would be null tool change events because the tool number did not change.
Okay, very good, thank you. Okay, and we'll keep moving. I'm going to jump over a couple here just to throw in a comment from Jay Kramer. Some machine companies supply or sell posts with their machine, where Thermwood would be an example of that. Thermwood, which is a very big player in the 5-axis router area. Okay, so I have a question. Let's see. This is from Santiago. Which vendor of CNC machinery do you recommend the most? Now, we work with a lot of different CNC machines, and we will always give you our opinion. And a lot of times our opinion will be based not necessarily on just the vendor for the machine tool, but it would be what vendor would we recommend for the kind of work that you're doing. But I wonder, Mike, if you would like to talk about that for a minute, just various different machine tool vendors. I'd just be interested to hear from you. What's your opinion on that, Mike? What's the best machine tool?
Well, I think a lot of it really depends on the local support in your area.
Good answer.
Yes, because I think there's quite a few top name, there's quite a few machines at every level, every price point and quality level, and it really depends. I think it really depends on what your local support is,
Right. So
That's
in that
huge.
case, I mean, we could talk about great machine tools, Makino, Morisaki, Herco, DMG. We could go on and on and on. Even, Haas is a great machine tool dealer. But you make a really good point. So when you're sourcing these dealers, you want to look at the machine tool distributor as well, because a lot of times that's who's going to supply your actual support. So the team that's going to come out, set up your CNC machine, and train you in it. When you buy your
Right.
first 5-axis machine, you're going to have an application engineer, and you may just have that person on site for 2 or 3 days. And
Right.
your programmer's got to try and learn everything. So support is absolutely as
It's
vital as the machine tool itself.
Yeah, definitely, because if they have to get on a plane and come from back east every time you need a support or a service call, it's going to get ugly fast.
and very expensive.
Very, very
Right.
expensive.
All right, great. Thanks for
Hey,
that, Mike.
Derek, I got a comment to throw
Yes,
in there too.
Colin, yeah.
I can't come out and officially endorse one manufacturer over the other because, we work with them all. I would say that the higher end Japanese machines are going to, give you the most accuracy for the money that you're going to spend. I think that's just a personal opinion, not an official position. But I think along with what Mike said with the service angle, service and support, are absolutely critical, spare parts. But the other thing to consider is the control options. A lot of people will be looking at the price point of the machine and thinking about, okay, how much horsepower do I get in my spindle, those type of questions, without also considering what do they got on the software end? Are they doing any kind of thermal compensation for the ball screws or the spindle? Are they doing any kind of workpiece error compensation, tool center point control, high speed? You can get a machine, you can load it up with high speed options, but if your block look ahead, your processing capability isn't fast enough, it won't matter. You're going to be maxing out at a feed rate that is less than the machine's capabilities because the software and the hardware in the controller can't keep up. So I think if I were in the market for a 5-axis machine, what I would do is to come up with one of my tougher parts, and I would go to each machine tool vendor and say, here's a CAD model or a Mastercam model or CAD model of one of my more difficult parts. I want you to program this for me and show me what kind of cycle time that machine can achieve. What kind of options are you using? Can I set this up in one place on the machine, programmed for a certain location, and then realize, oh, guess what? I moved my vise over an inch. Does that mean I have to re-post process the entire job? Or is the machine's control capable enough to, just let me change a work offset location and have all of those changes trickle down because the machine's control is doing all the heavy lifting in the background?
Right. Excellent point. Okay. Thanks for that, Colin. Thanks, Mike. You guys make very good points. Moving on to a question from Juan. Is the generic Haas 5-axis post included with the Mastercam license? And bear with me a moment. I'm just going to need to expand this again. Well, this is fantastic technology, guys, but sometimes it throws me for a loop. Okay, let's try that again. Is the generic Haas 5-axis post included with the Mastercam license ready to output good code for the Trunnion type Haas machines and for the new Haas UMC 700, but I believe that's actually a UMC 750. And as we have Colin here from CNC Software, I think we'll let Colin handle that question.
Sure. So the answer is we do ship a generic Fanuc VFTR series post with Mastercam. We do take that post processor out of the box and we run it on the VF4 with the TR210 table that we have in our shop. So we know it does work, at least for us, out of the box. But here's the tricky thing. I guarantee you that you could buy two quote-unquote identical 5-axis machines and you could stick them on your shop floor and there would be differences between them. And that has to do with the fact that every machine's control has parameters. And so depending on who set up that machine and how they set it up and what parameters they entered for the rotary axes and so forth would drastically influence how close that output is out of the box. So I think in most cases, most of the time, you're going to get a generic post like that, and it is going to require some type of small modification. It could be as simple as you post it out and you're like, you know what, I don't like the date and time format. I really want AM, PM instead of a 24-hour clock. Or I want it to say February 2nd instead of 2/2/2014. So there are always going to be modifications or things that you would desire to be changed. At least that's my opinion. But I can tell you that we do run the Haas VFTR out of the box with that post. Now, the second part of that is, will it run the UMC 750? No, and here's why. The configuration on the UMC 750 is different than the VFTR. The UMC 750 has a C-axis as the primary, which is the vertical axis that spins around Z, but it utilizes a B-axis to tilt the table, which rotates about Y and not about X. So the configuration's a little different. The other thing that happens with the UMC 750 is that the UMC 750 has some new control options for Haas. So with the UMC 750, they have implemented dynamic work offset, which is DWO, and that's used for 3+2 machining, and that allows you to program the part anywhere and then move the part anywhere on the table and allows the work offsets to follow it. And the other thing they have for the UMC 750 is tool center point control. So tool center point control is a live 5-axis option that allows basically dynamic tool length compensation on the fly with a 5-axis program. The reason I know so much about this, by the way, incidentally, is that CNC Software has been working directly with Haas Corporate on a new post processor for the UMC 750. So I've actually been working with some of the application engineers at Haas to develop this new post processor and to make sure that all of those functions for the UMC 750 are fully supported. One of the things that's different about the UMC 750 is that post processor is not free. It is a chargeable post from CNC Software. So we are trying to partner with Haas and have them recommend our post processor because we put a lot of time and energy and work into making sure that it functions as Haas intended to be able to run that machine tool. So if you do purchase that post, you have to purchase it through your Mastercam reseller, and it also comes with machine simulation models. So you'll have a full set of STL files for MockSim. So not only can you program the part, but then you can load it into machine simulation and make sure that it'll fit in there. Now, there is a caveat to that. The machine simulation runs the NCI code, so it's not currently running the NC code that's generated out of there. For anybody getting into 5-axis, I would still strongly recommend they consider either NC Simul or Vericut, something that will do full 5-axis simulation of their actual NC code. But at least the simulation models you get with the UMC 750 will at least let you, prove out the initial setup. You want to be sure that, the part is going to fit in the rotary travel limits, things like that. So if you program something that is going to violate a travel limit, it'll at least let you know. It's not going to verify the actual NC code, but it'll get you a lot closer than not having it. That's for sure.
Right. And I can say that Mike and I have been using the Mastercam machine simulator while we get Vericut set up for a client. And as you said, while it doesn't do everything, it's definitely a lot better than having no simulation at all, because that would just be a nightmare. So we have a question coming in from Craig. How do you handle mill turn post? How do you handle a mill turn post like an Akuma MU 500 VA? It's a trunnion machine with some turning.
I would say that you need to buy a customized post processor for that machine.
Okay.
So as far as I know, we don't have any generic 5-axis post processors that also have lathe capabilities. There are certainly plenty of vendors out in the marketplace that have posts that will support that machine, but you're going to have to go specifically to them. I'm thinking of somebody like In-House Solutions or ICAM, or maybe Camiax out of Germany. There are certainly several vendors in the marketplace that will do that.
Right. And we should mention that when you're getting into complex post-processing development, those really are, there are people who, that's their career. That's what they do for a living. They develop posts. So they have a very high level of expertise in the post-processor development. I have one coming in. Let's see. We have a question coming in from, I'm probably going to mispronounce your name, so I apologize ahead of time, from Ugur from Istanbul in Turkey. what do you think about a Mastercam 5-axis programmer looking for a job in Europe or worldwide? So maybe I can handle that for a minute, and anyone out there, any of the panelists who would like to jump in, or indeed anybody out there listening in has a comment, go ahead and speak up. But I can tell you that in my experience, I'm here on the West Coast in Silicon Valley in California, and most of the people who I know in the machining industry, certainly machine shop owners or executive supervisors in larger companies, I'm getting the question all the time, can you recommend a 5-axis programmer? I've taught classes at De Anza College for quite some time, so I do have access to a lot of people in the industry and a lot of people who are being trained. And I would say right now it's a seller's market. There are not enough 5-axis programmers out there who have the skill and experience to solve the problem. Now, 5-axis is a complicated subject. I mean, as Colin's already mentioned, there are lots of different 5-axis configurations. There are lots of different CAD/CAM programs that you may use. You need to know machine simulation software. You need to know something about post-processor development. So I'm starting to tell people, as I mentioned earlier, that you may not be looking for just one person to solve your 5-axis problems. You may need a team of people, because this is, it's getting more and more complicated. It's new technology, and really out here in the United States, the workforce is not really being developed fast enough to keep up with the technology. And I don't know if anyone else wants to have a comment on that. Okay, looks like they're going to let me run with that one. Okay, let's see. Oh, sorry.
Hey, Derek.
Yes?
Derek, I was just going to say that, when it comes down to that, if you've really got good skills that are marketable, like 5-axis programming, I'd say get in touch with a recruiter. LinkedIn is probably a good source for that. And depending on where you're at and where you're at in life, the other thing to consider is, I've heard an old saying that was, when I first got in the trade, and that's you gotta move out to move up. And that's really just what that really just means is that, a lot of the times if you're really looking for that next stage in your career, you got to look outside your local area, and you got to consider traveling. So working with a recruiter to be able to do that might be the step you need to take to go from Istanbul to somewhere in the European Union, and then get some work experience there, and then look to another recruiter to maybe try to get one of the tech worker visas. I know they've got they bring computer programmers in to like Microsoft all the time, from other countries, India especially. So I would say that if you've really got good 5-axis experience, especially experience in programming, that you'd probably qualify for one of those highly skilled worker immigrant visa, if you were looking to work in the United States.
Sure, and I think you're referring to the H-1B visa.
Yep.
For here in the United States. Yep. Great. Okay, let's see. We have a question coming in from Kurt. When you purchase a post from CNC, do you get the full code?
Most of the time, no. If you are purchasing a post, most of the math calculations are encrypted. So most of and it is rare for, I should say, the business model for CNC software in a lot of ways in regards to post-processors is changing. So historically, we have relied on the reseller network, which, if you've been around long enough, you may have heard them referred to as a value-added reseller, a VAR. Part of that added value used to be that, when you needed a post-processor, you would go to your reseller and they would do the configuration for you. Well, times are changing, and post-processors are getting more and more complex. So for example, in the case of the UMC 750, there would be portions of that post-processor that are unencrypted. So you would be able to go in and make some changes on your own. But a lot of the math calculations that are done are in the encrypted portion, and that's not going to change. You know, we don't release the internal code for the 5-axis post-processor. Now that said, one of the things that we'll be doing in my 5-axis post class is going through and writing a very simple 5-axis post on our own. So if you were really computer savvy and you liked to do programming and you wanted to get into post-processor development, we certainly have a full set of documentation available, and all of our math functions are documented. So you've got access to all of that stuff. So assuming you had, the math background, you're going to get into some multivariable calculus, some vector and matrix math programming, you could certainly write your own post processor. So the answer is that even with the generic posts that are free, there are sections of it that are encrypted and you do not have access to. Now, when we go through in our class and we look at the generic Fanuc 5xmil post, I will show you how to do some debugging tips and tricks, because all of the output that occurs from the non-encrypted portion of the post. So I can guarantee you that every line of code that is output, the calculations may be done elsewhere, but the output occurs from the post section. And what that means is that if you know how, you can overwrite it. You can write your own code, you can check certain variables, and you can say, you know what, if this condition is true, instead of outputting the normal output, I'm going to call my own post block and I'm going to do my own calculations. So with the generic Fanuc 5xmil post and all of its derivatives, you should have access, I know because I do it every day, but you should have access to all of the sections you need to get whatever output you want.
Okay, fair enough. Okay, everybody. Well, we're running about 10 minutes over, so I'm going to go ahead and call this off for today. I do encourage you, if you have further questions, just send us an email. You can send questions to derek@eapprentice.net. That's D-E-R-E-K. You can send questions to colin@eapprentice.net or michael@eapprentice.net, and we'll do our best to help you. So go ahead and do that if you have more questions. And of course, if you're interested in taking Colin's Mastercam post-processor course, it's a live course beginning this Saturday. It will be limited to 25 students. We cap it off at 25 people. It's one-on-one interaction with Colin, and I don't think there's a better deal to be had out there. So I'd like to thank the panelists today, Colin, Michael. We also had Bo online, just kind of sitting in. Bo's a Six Sigma lean manufacturing expert, and he was hanging in there in case questions went that direction, and we appreciate you being here, Bo. And we will have a webinar coming up next month that will focus on those subjects, lean manufacturing. So I'd like to just say thank you to all of you. We do appreciate the time that you spend here with us. I know a lot of you on the West Coast are coming in missing some work, and those of you out on the East Coast are missing time with your family. So that's it for today from us at eApprentice. Thank you very much, everybody, and we'll see you next time.